Hello class, welcome back to another section of our course. In this video, I'm going to share with you isolated points and limit points. This is one of the most confusing parts of calculus. Kindly stay tuned, watch this video to the end and you are going to understand it very well. Don't forget to subscribe if this is your first time visiting this channel. So, isolated points and limit points. The word isolated basically means something which has been separated from the entire population or entire group. So once you are separated, it means that no other member of your group is closer to you. And at any instance, if we take any neighborhood around you, you shouldn't find any of the other members. But for some distance away, you may find some. But if you take any short distance around that thing and you don't get other members, means that thing has been isolated. Now let's take a class for example. If you have a class sitting down sitting at a row and one person is separate to sit somewhere, that person is said to be isolated because that person, around that person, you can't find any other member of the class, but where you are going to find other members. We are going to employ this in calculus. So when I said isolated points, what am I talking about? Isolated points are points in an interval, so that if I take any, so let's say isolated points, say x naught. Yes, I have an isolated point, say x naught, which happens to be a real number. And this isolated point, I'm saying that it's an isolated point of a subset of a real number s. If I take any delta neighborhood around x naught, then if x naught is indeed isolated point, there shouldn't be any value of this delta that will give me, if x naught is indeed the isolated point of this s, then there shouldn't be any value of delta that will give me a set or an interval in which I wouldn't find any element of this s within. I come again. If s naught is isolated point, then there shouldn't be any delta, any value here, that when I find a neighborhood around x naught, the interval that will give me will exclude all the members of s. Now let me make it so simple. So assuming I have found the interval around x naught with a certain delta, so if I get a, let's say a minus delta, then comma open a plus delta. So this is a neighborhood around x naught. So all that I'm saying is, since x naught is my center, here will be x naught. So x naught minus delta, x naught plus delta. So all I'm saying is there shouldn't be any instance where this interval will exclude all the members in this s, or there shouldn't be any instance where I wouldn't find any member of this s within this interval. So for any delta I choose, if that point is not isolated from its members in the group, then I should find other members in it. That is the basic meaning. So if I choose two neighborhood of my x naught, I should find other members. If I don't find any other member, then x naught is an isolated point. So in summary, all that this is saying is that at least, even if you get one value of the delta, that gives us an interval. Let me cancel this interval and write it all. X naught minus delta, comma, x naught plus delta. So within this interval, there shouldn't be any value, or if at least I get even a single value of delta, that gives me this an interval in which I can't find any other member of this set in it, then I'll say that my S0 is isolated. That doesn't mean that there wouldn't be any delta which you wouldn't find other. Some delta, when you choose, you surely get other members, but that doesn't conclude. Even if I get one value of a delta, that resulted in an interval in which I didn't find any other member of S, then I'll say that this X0 is an isolated point. So I have an example here. So it's saying that I have an X which is 0 union open brackets angle bracket 1 comma 2 like this. So this means that I have 0 union this interval, meaning 0 is part of my interval, or is part of this set, and I have this interval. So within this interval, I start from 1 inclusive and ends at 2, but the 2 is not part. Yes. So let's take notes. Then the next thing to do is, when I come here, they're asking me that what is the isolated point? I mean, isolated points that I'm having here. You want to see that this set that we are having, if I choose an X0, let's say 0 from this set, this is my X0. So X0 is a member of the set. If I want to see that this 0 is indeed isolated, that is when I'm going to choose any delta value. I'm going to choose, it's an arbitrary delta. So choosing a delta, say the delta should be greater than 0. So you can choose a delta, let's say 0.1. It should only be greater than 0. That is positive, but it can be as small as possible. You know that in an interval like 1 to 2, you can have a member as 1.00001. It's still part of this interval. Yes. So even if you take a neighbor, a delta, a radius which is very, very small, you should get a member of the interval within. If not, then we say that this point 0 I've chosen is an isolated point of the set. So let's see. If I choose delta to be 0.1, then if I take the 0.1 neighborhood of 0, I'm going to get it is a minus, so a 0 minus 0.1 less than x, then less than 0 minus 0 plus 0.1. So I'm going to have an interval where I'll get negative 0.1, sorry, open, then comma 0.1. So let's see this interval. I have from negative 0.1 to 0.1. You can see that in this interval, the maximum I can reach is 0.1. And within this interval, I'm starting from negative 0.1. What does that mean? So when I look into this set, and mind you, for the isolated points, one thing to take note of is the number you chose as a center should not be considered when you are considering the member in the set which are present in the interval. So this is my interval that I've got right now. This is my set. I choose 0 from this set as the isolated point, and I'm testing for it. So how would I know that 0 is indeed isolated point? Now when I compare this interval and the set, and I found out that aside a 0, there is no other member in this set being present in the interval, then I can conclude that 0 is indeed isolated point. So when I take this 0 out, I'll consider this interval here. From 1 to 2, we can't have any number in this interval which will fall here. No. Because the maximum is 0.1 and this is starting from 1. So therefore, I can say that 0 is an isolated point of the sets S, or something like that. So that is all for isolated points. Let's go to limit point. What is a limit point? When we say a limit point, what do we mean by a limit point? So a limit point, which is also called a cluster point or point of accumulation. Point of accumulation. So you know, when you say limits, basically limit is where you can't cross, or your boundary, or the maximum you can reach in anything you are doing. So therefore, if I say a limit point, all that I mean is this is a member, or the limit point is any number, so that if I find any delta neighborhood of that number, I will get at least a member of the set in it. So this is directly opposite to the isolated points. So not necessarily opposite though, but the limit point, what is saying is, whenever you find any, let me use every, yes, every delta you choose, yes. So for the limit points, every delta you choose should give us at least one member of the sets, yes. So every delta you choose, after you have found the interval or the neighborhood, you should get at least a single member of the set. And number two, the limit point itself shouldn't be included. So if I take the limit point to be, let's say 0, and this limit point is in the set, when I'm considering the members which appeared in my interval, I don't include 0, yes, I take 0 out. So limit point is saying that for every delta you choose, you should get at least one member of the set. But when you talk about the isolated point, it is saying that if you choose any member and it happens that in your interval you are not getting the members of the set in it, then it is isolated. But in the limit point, it's saying that for every delta you choose, at least you should get one member of the set in it. So that is the main difference. Now let's see how we do it. So we have another example here saying that 0 is, let me show you, 0 is the limit point of 0, 1, which is an open interval. So they are saying that 0 is the limit point of my interval 0, 1. So therefore, how do we prove this, or how is this true? From the definition and my explanation of limit points, when I take any delta, so delta says 0.1 again, so my delta is equal to 0.1 again, then the neighborhood, 0.1 neighborhood of 0 should give me an interval. And what it is saying is that interval should contain at least one member of this set. Yes. So let's see. 0.1 neighborhood of 0 is going to give me 0 minus 0.1, comma 0 plus 0.1, and open. So this is going to give me negative 0.1, comma 0.1. Yes. So this is my neighborhood, and this is my interval. What do? I need to compare. Do I have any member of this inside? I'm starting from 0 here, so I'll surely have 0.1 somewhere. I'll surely have 0. Let's say I'll surely have 0.11, sorry, I say 0.1. I can surely have 0.001, and in this I can also have 0.001. So from that we can see that this neighborhood has a lot of the members of this set, hence 0 is indeed the limit point. There are some few points to take notes in this class or in this section of calculus. It said no finite set has a limit point. No finite set has a limit point. That is, every finite set, for example, if I take a finite sets 1, 2, 3, 4, 5. If I take a set 1, 2, 3, 4, 5, it can't have any limit points. In that, if I take any number, let's say 4, and I find 0.1 delta neighborhood. So if I take a delta like 0.1, I'm going to get 4 minus 0.1, which is 3.9, comma 4 plus 0.1, 4.1 as my interval. Within this interval, I can't find any other elements. All the elements are whole numbers. So I can't find any other elements. We don't use, these are fixed numbers, they are not intervals. So you have 1, 2, 3, 4, 5, and they are distinct numbers. So if I use any delta, I'm not going to get. So whenever you see any finite set, it doesn't have a limit point. Then secondly, he said an infinite set may or may not have a limit point. A typical example of an infinite set which doesn't have a limit point is a set of natural numbers. Yes. So a set of natural numbers start from 1 to infinity, but it doesn't have a limit point. This is because natural numbers do not have, let me make this scenario here. Natural numbers do not include 0, do not include decimals, as well as rational functions. And we know that whenever you take an integer, rational functions, or rational numbers, let me make it rational numbers, and we know that between any two integers, there are a dense of rational numbers. For example, this 0 and 1 here is an interval, and there are lots of rational numbers within. You can have 0.001, 0.00001, and they are all not natural numbers. So a set of infinite natural numbers do not have a limit point. Then we can have other sets which will have a limit point but infinite. Now let's see. When I take this, he said this set has no limit point. This is because this is a finite set. This is all I have for you in this lecture, and let me see a class. Thanks for watching, and I hope you have really understood isolated points and limit points. If you have any misunderstanding, pin it in the comment section and it will be dealt with. I'll be posting a lot of tutorial videos on isolated points and limit points, so don't forget to subscribe and switch on the notification button. Thanks, and don't forget to like the video.